There's your answer. Okay, so now we got some rules to deal with. There are 3 basic rules for operation with logarithms that you must know. They are as follows. Whenever you're multiplying here, you can change it to 2 terms being added. Whenever you're dividing, similarly, but kind of opposite, whenever it's dividing, you can change it to 2 terms being subtracted. And then this third one here, we take this power, we can pull it out to the front, it becomes b log a. So when I look at these 2 numbers here, we got to remember a couple of things. This is 10, this is 10 because it's a common log. They didn't give us a base. So this is really log base 10 of 25 times 4. Well, 25 times 4 is really 100. So now think about this for a second. 10 to x power equals 100. What would this be over here? It equal 2. So that whole complicated double term, weird common logs is just simplified down to 2. Similarly over here we have 40 minus 5. So when I see the minus sign, that tells me that it was originally dividing. So I'm going to take those 2 pieces and I'm going to divide them. Give me log base 2 of 40 divided by 5. Let's simplify that even more. Log base 2 of 8. Now let's ask our question using that fundamental translation between logs and exponents. It's saying 2 to the x power equals 8. 2 to some power equals 8. It's 3. So this equals 3. Okay, now we got a whole lot of stuff going on here. Notice that I have 2 logs. I can probably put those together because I have a plus sign. I have to also set it up so we use this 3. So I'm going to first combine them, use the 3, rewrite it, and then do some algebra to solve. So I have log base 4 of x plus log base 4 of x plus 12. What do I do when I have a plus sign? Whenever I have a plus sign, that means I can take it back to multiplication. So that means log base 4 of x times x plus 12. All of that equals 3. Well, let's go ahead and get this out of the logs and start doing some regular algebra with it. I'm going to say 4 to the 3rd power equals this whole piece on the inside in those parentheses there. So 4 to the 3rd power equals x times x plus 12. 4 to the 3rd power would be 16 times 4, which is 64, equals x squared plus 12x. Now if I'm trying to solve a polynomial of degree 2, a quadratic type function, I can try to factor it. So let's see if I can factor it first. We need some extra space here. So I'm going to subtract 64, set it equal to 0. X squared plus 12x minus 64 equals 0. Now you want to ask yourself, are there 2 numbers that multiply to 64 but add up to 12? And it looks like it's going to be positive and negative. So I'm going to have one positive, one negative. How do I know that? Because they got to multiply to be a negative. So what multiplies to negative 64 but adds up to positive 12? Well, 16 being positive and negative 4 would work. So that means this is going to be x plus 16 and x minus 4. So if I solve each of these, that means this first one is going to be x equals negative 16 and the second one is going to be x equals 4. Now even though I have 2 answers, one of them works, but the other one doesn't. This one does not. If I were to plug in negative 16 into either one of these terms, I would be taking the log of a negative. And because our domain has to be greater than 0, or our range has to be greater than 0 for exponential functions, that means for logs, this x has to be greater than 0. Because you can't take the log of a negative number. So that means the negative 16 is out. 4 would be your answer. That's all we have for review here. If If you guys still have questions, go back and watch the video again or come and talk to me in class. The end.